Hi, the objective of this video lesson is to find the 6 trig functions for an angle of a right triangle. So I have drawn for you a right triangle. Recall a right triangle is a triangle in which one of the angles is a right angle or 90 degrees. And I've labeled one of the other angles in the triangle as theta. And now we can talk about the sides of the triangle in relation to this angle theta. The side here in green is called the side adjacent to theta, and then we have the side opposite of theta, and lastly we have the side opposite the right angle, which is always denoted by the hypotenuse. Now we can also talk about these in terms of like A, B, and C. And the standard way we denote these in terms of A, B, and C is we use the lowercase letter opposite that side to denote the side of the triangle. So the side opposite this angle A would be denoted with a lowercase a. The side opposite the angle B would be denoted with a lowercase b. And then the side opposite angle C would be denoted with a lowercase c. Now, we can make up 6 ratios using the sides of the triangle in relationship to this angle theta. And those 6 ratios are called 6 trig functions for theta. And one minor note to make here is that theta is always going to be an acute angle. Acute angle means that theta has to be between 0 and 90 degrees. Or if we use radians, we would say between 0 and pi over 2. And that is because the sum of the measures of the angles in a triangle is 180. Knowing that one of these is 90 degrees means that the remaining 2 have to add up to be 90, which means that they have to have a value less than 90. Now, these 6 trig functions are going to be critical for you to memorize. We have sine, cosine, and tangent. Those are the 3 primary trig functions. The other 3, which are called cosecant, secant, and cotangent, are actually the reciprocal of these 3 basic functions. So sine is abbreviated sin, so sine theta is defined to be the opposite over hypotenuse. So opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is defined to be the opposite over adjacent. And then cosecant is the reciprocal of sine, so it is hypotenuse over opposite. Secant is the reciprocal of cosine, so it is hypotenuse over adjacent. Cotangent is the reciprocal of tangent, and it is the adjacent over opposite. You may have heard a lot of mnemonics, those of you that have had trig before, with helping you remember these. I can tell you in high school, which was 20-some years ago, 25 years ago, my high school algebra teacher told me this cute little saying. He said, "Some old hen caught another hen taking oats away." It's very silly, but it has stuck with me all of these years, and that's the way I remember it. I've heard some people say Chief Sakatoa, but I could never remember how to spell Sa-ka-toa. But if you can remember that, then you can use that to say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Whichever way you can to remember those, please commit those to memory. And then you also have to memorize which function is defined to be the reciprocal of sine. It is cosecant. The reciprocal of cosine is secant. So that seems to be kind of backwards. If you're using like sine, you might think goes with secant, but it does not. It goes with cosecant. Cosine goes with secant. Now, the other things you need to remember about right triangles are that we have the Pythagorean theorem, which is a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. And I've already covered this briefly, but angles in a right triangle, we know that they sum up to 180, so the other two angles have to have a sum of 90 degrees. Okay? Now, let's take a look at a couple of examples of how we can find the 6 trig functions of an angle theta. So I have a right triangle here. Notice that I know only two sides. I know the hypotenuse is 13, and I know the side opposite of angle theta is 5. But to be able to compute the trig functions, I also need to know the adjacent side. So the very first thing I need to do is find out what the missing side of the triangle is. So we can use the Pythagorean theorem to say that 5 squared plus x squared is equal to 13 squared. So that gives us 25 plus x squared is equal to 169. If I subtract 25 from both sides, I get x squared is equal to 144, and applying the square root gives me that x is 12. So now I can find the sine of theta, cosine theta, tangent of theta, and so on. So sine of theta is defined to be, if you remember some old hen or Chief Sakatoa, it is always the opposite over hypotenuse. Well, where is the opposite? So we're talking about this angle theta, so its side opposite is 5. And what about the hypotenuse? Yeah, it is 13. It's always the side opposite the right angle. In fact, you may want to make a note. This is the side opposite. This is the side adjacent. And this is the hypotenuse. And I don't think I used the same color scheme I did on the previous drawing, but that's okay. Now, what about cosine of theta? Cosine of theta is adjacent over hypotenuse. So it would be 12 over 13. And what about tangent? So this is some old hen caught another hen taking oats away. And so opposite over adjacent would be 5 over 12. Okay, now I can do the reciprocals. So we have cosecant is going to be hypotenuse over opposite. And I tell you, I don't memorize the cosecant, secant, and cotangent. I just know them based on the other three functions. So hypotenuse over opposite would be the reciprocal of 5/13, which would be 13/5. The secant is the reciprocal of cosine, so it would be hypotenuse over adjacent, which would be 13 over 12. And then lastly, we have cotangent of theta is going to be adjacent over opposite, which would be 12 over 5. Okay? Now, the last example I want to do with this is to sketch a right triangle that corresponds to the given trig function, then find the 5 other trig functions of theta. So now we're told we have sine of theta is equal to 3 over 5. Well, remember what sine of theta is. It's the opposite over hypotenuse. So that tells me that if I draw a right triangle, and preferably a pretty nice right triangle, and we know that we have a right angle here. Now theta in this case can be either angle. Let's just make it here. So the opposite side is going to be 3, and the hypotenuse, which is always the side opposite the right angle, is 5. So you should notice a similar approach to the last problem, that we know two sides, we're missing one side. So the very first thing I need to do is find out the missing side using the Pythagorean theorem. So we know that 3 squared plus, we can call this x squared is equal to 5 squared. So we get 9 plus x squared is equal to 25. We can subtract 9 to get 16, so therefore x is 4. So now we need to find the remaining 5 functions. If we know sine, now we can find cosine of theta. So cosine of theta is adjacent over hypotenuse. And just be careful where we're looking. Here is my angle theta, so the side adjacent to it is here, which is 4. The hypotenuse is 5, so that would be 4/5. Tangent, some old hen caught another hen, taking oats away, so it's opposite over adjacent. So the opposite side is 3, the adjacent is 4, so that's 3/4. And then the reciprocals, so we know that cosecant is the reciprocal. Oops, I left out my theta there, tangent of theta. Cosecant of theta would be the reciprocal of sine, which would be 5/3. Secant of theta is the reciprocal of cosine, which would be 5/4. And then cotangent theta is the reciprocal of tangent, which would be 4/3. Okay, so if you have any questions, really the whole objective is just to learn those definitions of what the trig functions are defined to be, and then find a missing side using the Pythagorean theorem, and then just fill in with the sides to get the values that you need. So if you have any questions, please contact me.